finding gradient using a graph. The gradient of a line is its slope, how steep it is and which way it's sloping. Its symbol in maths is a little m, and the way we find it is we do rise divided by run, and I'll explain more what that means. It can help to think of rise as how much the graph has gone up or down, and run how much the graph has gone across. And these give us an idea of what we mean by that. See, this slope isn't very steep. In this graph, our rise is 2, and our run across is 1, 2, 3, 4. 2 divided by 4, a gradient of a half. Not very steep. In this one, our rise, how far it's gone up from this dot to this dot, is 1, 2, 3, 4, 5, 6. A rise of 6, and a run 1, 2, 3, 4 of 4. A much steeper line, that's actually, we should have got a nice even number. That's 3 over 2. Steeper. I'm sorry, I should have got you a better one. This graph isn't a rise from here to here, it's a drop. This will have a negative gradient. So this is steep because it's going up a lot for across not very much. This is not very steep, it's going up not much for across the same amount. This has no gradient, a 0 gradient, because it's going nowhere. It's not going up at all. And this has an infinite gradient because it's going up forever, because lines keep going. Don't worry too much about these. I should have picked you a better example. I'm sorry. I was just trying to look at why a big rise and not very much run gives me a big slope. So sloping up across the page, left to right, the way we read, positive gradient. Sloping down across the page, the way we read, negative gradient. Horizontal line has 0 gradient, vertical line has an infinite gradient. So if they ask us to find the gradient of a line, the easiest way is from a graph. And we remember that gradient, m, is rise over run. From the graph, we work out how far the graph went up for how far it went across. So this is a positive gradient, it's sloping up. From this point to that point, how far did it go directly up? 1, 2, 3, 4. A rise of 4, how far did it go directly across? 1, 2. A run of 2, and 4 divided by 2 means we've got a gradient of 2. For this graph, you can see we've got a negative gradient. It's sloping down across the graph, the way we read. But we do this exactly the same way. Gradient is rise over run. How much it's gone up or down by how much it's gone across. So from this point to this point, the rise is actually a drop of 2. So we'll say negative 2. And the run, 2, 3, 4, is 4. And if we divide that out, we get negative 1/2. Because a gradient can be a whole number or a fraction. When it's a whole number, it's actually got over 1, but we'd just think of it as a whole number. So that's how you get a gradient from a graph. If you're asked to find a gradient between 2 points, because this point is negative 4, 3, and this point is 0, 1, then the easiest way to do that is just to graph those 2 points, find the rise and the run from the graph, and get your gradient that way. You can work out the rise and the run just from 2 points, and that's in today's core video if you'd prefer. Now you'll notice I didn't label these lines when I graphed them. If I go back and label them, y equals 2x plus 1 is this graph, and this graph is y equals negative a half x plus 1. You'll notice that the gradient is actually given to us in the rule of the line. This graph has a gradient of 2, and there it is, it's the coefficient of x in front of the 2. This graph has a gradient of negative a half, and there is negative a half in the gradient, in the rule of the line. The rule of the line also tells us where the graph cuts the y-intercept. Both of these are cutting the y-axis at 1. So that is our y-intercept. So if they told you the rule of the line, you could get the gradient straight from in front of the x, and you wouldn't have to find it with rise over run. If they asked you for the rule of this line, when you knew its gradient and its y-intercept, you could work that out, and that will be in one of the core videos coming up.